lesson 8D, and we're going to talk about some basic probability concepts and how to make calculating probability a little bit easier as we go on in this particular unit. So the union rule for probability is similar to the union rule for sets. If you are counting two things together, two events together that could happen, like it's either this or that. Well, maybe some of those elements have both qualities. So at that point, you'd have to watch out for the double counting, like we've talked about before. If you're talking about a complement rule, let's say that the event you're concerned with is rolling a 5 on a 6-sided die. Well, the complement of that event would be not rolling a 5 on a 6-sided die. So it's logical that probability would be 1 minus the probability of the complement and vice versa. So let's kind of see how those work here in these examples. The union rule is very simple to do here. If you want to draw a single card from a standard deck of cards and you're finding the probability that the card is red or it's a face card, well, 26 out of the 52 cards are red, and 12 out of the 52 are going to be face cards. However, I have to take out for the cards that are both red and face cards. So Jack, Queen, and King of Hearts, Jack, Queen, and King of Diamonds. That makes 6 of the cards that are being double counted here because those 6 are both red and face cards. So you can really only count them once just to make sure that you get them right. So this is where this minus the intersection comes into play. So 26 and 12 is 38. 38 minus 6 is 32. All right, let's get that to write correctly here. 32 out of 52. And you can cut that down, I want to say by a factor of 4. So 8 out of 13, I think, is going to be the reduced fraction that expresses the probability there. So 8 out of 13. Okay, not too bad to do. You just got to watch out for the double counting. That's the catch. Okay, so let's do another union rule 1 here in part B. The card is less than 4 or it's a heart. Okay, well, less than 4. That means it is an ace, a 2, or a 3. And if there are 4 of each of those in the deck, well, then you have 12 cards that are going to be less than a 4. 12 out of the 52 that are less than a 4. Now, the catch with the heart is that there's 13 of those. There's always 13 of every suit, so I've got to add in the hearts. But the problem is I am double counting 3 cards. I am double counting the cards that are not only just the less than 4, but they're also hearts. So the ace, 2, 3 of hearts, I'm double counting here. So I have to subtract those out, all 3 of those. Getting it to do the right thing here, 3 out of 52. Okay, and then when I subtract that out, I'm going to end up having, well, let's see, 12 and 13 is 25, and then take away 3, that's 22 out of 52. And I can only reduce that down by a common factor of 2. So I'm thinking 11 out of 26 is that particular probability right there. Okay, so not so bad to do. All right, so again, you just got to watch out for the double counting here. And this is where things get a little bit exciting. So the card is not a spade. Well, sometimes it's easier to think of the complementary event and subtract the probability from 1. So rather than counting all the cards that are not spades, it might be easier to count the cards that are spades and take that probability away from 1. So I'm going to do 1 minus the probability that the card is a spade. And the probability that the card is a spade is, of course, 1/4, or 13 out of 52. I'm going to reduce this all the way down because it's just going to be much easier to do the math in my head, and I'm going to quickly come up with 3 over 4. Okay, the card is not red or a face card, so if it's neither one of those things. So this is where I'm going to have to be really, really careful. Well, if it's not red, then 26 out of the 52 cards are not red. Okay, well, if it's not a face card, well, there's only 12 in the deck that are face cards, so if it's not a face card, that's 40 of them. Okay, but now I have to take out the cards that are not red and not face cards, and that's going to be 6 of those altogether. I think this is kind of maybe it's an easier way to look at it this way. If it's not red or a face card, okay, well, let's think about, let's redo this and think about the process here. The card is not red or it is a face card. Okay, well, if it's not red, then that's 26 out of 52. And if it is a face card, that's 12 out of 52. I think I misinterpreted the problem here because I was going to get something bigger than 1 if I kept going. And then the cards that are both not red and face cards are all the face cards that are clubs and spades. That's much better. So 32 out of 52, and again that reduces to 8 over 13. Okay, so not too bad to do there. Not too bad. We've just got to kind of stop and think about unions and complements and what's going to make our life a little bit easier to do the probabilities. All right, let's go on here to this example. 2 fair dice are rolled. Now, I've posted a chart that is on the website there that will help you to kind of remember the pattern for this. If you discover the pattern for yourself, rolling 2 dice has a really, really, really nice symmetry to it. I'm going to see if I can also get a video up there to show you that particular rolling 2 dice chart, so that way you can see how it's built and you understand that there's a really, really easy way to do this. Okay, so if the first die shows a 2, well, the thing that you have to keep in mind that with 2 fair dice, there are 36 outcomes, not 12. A lot of students, when they first learn that, just have a little bit of a surprise that there's 36 outcomes. Well, 6 outcomes on the first die, and then you can pair those off with 6 outcomes on the second die. So you could get a 1 and a 1, a 1 and a 2, etc. You can get a 2 and a 1, a 2 and a 2, etc. So now you can kind of see where that's getting to 36. Okay, so if the first die shows a 2, 6 out of our 36 outcomes will have a first die that shows a 2. Okay, now, or the sum is 6 or 7. Okay, well, this is where things get a little weird because to get a sum of 6, 5 out of the 36 outcomes will be 6s. You can get a 1 and a 5 and a 1. You can get a 2 and a 4 and a 2, or you can get double 3s. Those are the 5 outcomes. Okay? 7 is the most commonly rolled number, and 6 out of 36 outcomes have 7. You know, 1 and 6, 6 and 1, 2 and 5, 5 and 2, or 3 and 4, 4 and 3. Okay, now, I am double counting here, though, because I could roll a 2 and still get a 6 or a 7. I could get a 2 and a 4 to get 6. I could get a 2 and a 5 to get 7. So I've got to take out those 2 outcomes that they have in common. So let's see, 6 and 5 is 11, and another 6 is 17. Minus 2 is 15 out of 36. And if I divide everything by 3 here with a common factor to reduce, the probability is 5 out of 12 that I will roll a first die shows a 2, or I get a 6 or a 7. That's not too bad, but we just had to stop and think about it for a minute. All right, so the sum is 3 or it's 10. This one might be a little bit more challenging. there's only two ways to get a 3, 2, 1, 1, 2, 36 outcomes there. And there's three ways to get a 10. You could get 4 and 6, 6 and 4, or you could get double fives. They don't have any outcomes in common. You can't get a 3 and get a 10 at the same time. Those things don't work that way. So 5 out of 36 is that probability. There's no intersection to subtract there. Okay, and then once again for the complements here, if the sum is a 7, I want to find the complement of that event that's not rolling a 7. Well, it might be easier to find 1 minus the probability of rolling a 7. Okay, well the probability of rolling a 7 is 6 out of 36, which is just 1/6 if I reduce it down. So the probability of not rolling a 7 is 5 out of 6. Okay, so far so good. You know, we can kind of do some Venn diagrams with probability also. So I'm going to take a moment and just get a Venn diagram up here because it's going to help us out. The thing that you need to keep in mind with Venn diagrams is that the probability of any particular situation occurring, those probabilities always have to add to 1. So it helps to keep that in mind when you're talking about using a Venn diagram to describe probability. So we've got Susan being a college student who receives heavy sweaters from her aunt at the first sign of cold weather. The probability that she gets something is the wrong size is going to be 0.47. The probability that it is a loud color is 0.59. And the probability that it is both is 0.31. So what I'm going to do is I'm going to use this information on a Venn diagram first to help my cause. And this is going to be just kind of like the Venn diagram problems that we did before, where we had the DVD and the Blu-ray player, if you remember in the previous video. So I'm going to label these sets here. I'm going to label wrong size as W and loud color as L. And the probability that she gets both the wrong size and the loud color is 0.31. So that's where I'm going to put the 0.31. Now, if you remember what I had to do some subtraction here. So for the loud color, it's 0.59 total. And if 0.31 of it is in the intersection, then 0.28 is going to be out here. For the wrong size, if the total of that is 0.47 and 0.31 of it is in the intersection, then 0.16 is out there. So now I have to do a little bit of math to be able to figure out what goes in the universal set out here just really quick. So it looks like it's going to be, well, if I add those two from W together, it's 0.47. And then if I add 0.28 onto it, I'm going to get 0.75. So 0.25 is going to be what's outside here. So all of these probabilities have to add to 1. That's the key to the operation here. All right, so now I'm supposed to find the probability that the sweater is the correct size and it is not a loud color. Okay, so that means that it's got to be, it can't be the wrong size, so it's got to be outside of W. And it's also got to be outside of L because it won't be loud either. So I guess that satisfies everything that's out in the rectangle here. So the answer there is 0.25. Okay, now the fun part. I have to find the probability that the sweater is the correct size or it is not a loud color. Okay, so that means the probability that it is the correct size is everything outside of W. Well, that's not just the 0.25, but it's also this in L alone. So the probability that it is the correct size is 0.53. And since this is an OR, I'm going to do the union rule here. All right, everything outside of L is what's in W and what's in the universal set, which is 0.41 if you add those two together. But you notice I counted this 0.25 twice. I added that into both things. So I have to take that away as part of my OR, my union rule. So let's see if I can get this right here. It looks to be 0.94 minus 0.25. So 94 minus 25. Brain just suddenly locked up on me here. So I have to borrow and make that an 8. 0.69 is the way it looks. That's the probability that you get something that is the correct size or not lapped. Okay, that seems legit. Alrighty, so far so good on some of this probability. Again, it's just a matter of being very, very careful here. And that wraps up our lesson for today on this. We'll come back to conditional probability in the next lesson.